All right, I'm not really sure how this video is going to go because I'm just going to film this as I'm doing it, and I don't really know what I'm going to find. I've got here a couple of Z-Wave light switches, and so this is a Zooz Zen24 version 3.0 Z-Wave switch, and then this is an Inovelli. Open it up, and it's a paddle style switch, and both of these are a little bit older models. They're not current. And I bought these a while back. They're a little different. Obviously, this is a paddle versus a toggle style switch, but more importantly, the Zooz style switches require like a neutral, whereas this one didn't. And so I've got a house that's got some mixture of new versus old wiring, and not all of the outlets have neutral. Some of the outlets only have basically a line and a ground, and so depending on the way these switches work, you need one versus the other. I actually prefer the toggle style levers. I don't really care for paddles, but at the time this was the only switch I could find that had Z-Wave and didn't require a neutral. So I had some problems with this. They replaced it, and the newer one works just fine. Like I said, this isn't a current gen, but I thought it'd be interesting to open these up to see what's inside, see the differences, because again, there's something different about these on the inside with how they power themselves, because again, why one works without a neutral while the other one requires it, it's got to be something inside with like a transformer, some system, to rectify the AC voltage to power the microprocessors or other, kind of brain box inside of this thing. That's all I can figure. But let's open them up and take a look. So looking at these two, the Zooz is going to be easier to get into. I think it's got some security screws up here, some little triangle head security screws, whereas this thing, I don't know, it's got these 4 screws underneath the faceplate. Maybe that'll be how I get in there, but I don't know. I'm going to have to try to get that faceplate off. Let's start with the Zooz. Okay, so that's the casing off. So there we go. There's some of our guts there. So we've got all the little terminals. No problem. Looks like we've got some big inductor there, and cap. Looks like a fuse here, and then like a thyristor there. So I'm guessing all this in the back just looks to be power supply stuff. So this is an interesting little kind of layup here. You've got double-sided components on this board, and then there's a connector. Looks like, let's see, 1, 2, 3, 4, a 5-pin connector coming down to a bottom board. The switch, yeah, so this switch right here actually goes and toggles this little switch that comes through to this top board. Not really exactly sure what that's for. Maybe I'd have to go look at the instructions. And then you've got the toggle, and it's going to be kind of hard to see, but inside here, there's basically 2 buttons, 2 PCB mounted buttons. So whenever you push this up, it pushes one, push it down, it pushes the other. Let me see what I've got to do to get this thing removed. Okay, one issue is this rivet is holding on to, I'm not sure if it is a MOSFET or a triac or something, that's using this aluminum faceplate as a heat sink, and so it's been riveted on. So I'm going to see if I can drill that out real quick, because I don't need this switch. If I break it, it's no big deal. So let me drill that out and see what we can do. All right, got the rivet out here, so let's see if we can. There we go. So there's the switch that I was talking about. So this slider on the bottom just fits in here, and then you're basically just toggling this little switch. And there is the back of, again, whatever MOSFET or triac we've got. Let's get this thing broken down a little bit more. A couple little screws holding the plastic faceplate on. Aha! All right, so I mentioned that toggle was pushing on two buttons mounted to the PCB, and here they are. They've got a couple of springs, so whenever you're flipping this back and forth, it's got a couple of springs to help force the switch off of the buttons. But yeah, just a couple of buttons mounted to the PCB. I guess here's your antenna for the Z-Wave system. The board says NIE Tech. So I don't know if that's the company that manufactures the PCB or if that's a different name for Inovelli. So let's see what we were hiding here. All right, yeah, so this is an ST Micro. It's a BTA24 600B. So that is a 600 volt. I think it's going to be a 25 amp triac. And again, that was just mounted to the front plate for cooling purposes. And the little component here, this big chip, this is a full system on a chip. This is a Silicon Labs SD3502A-CNE3 Z-Wave chip. This thing, you know, it's not cheap. That chip from Mouser costs over $11 just for that one component. Now, I'm sure they're getting it in quantity, but it is just a Z-Wave specific chip. Let's see what we've got here. And this little 8-pin package here, that is an Adesto AT45DB021E, which is just some SPI flash memory. Looks like 2 megabit flash memory. So memory, system on a chip. Here's your big triac. And I don't think this thing unplugs. So these are soldered together right here by a big insulated bridge, it looks like, that comes through here. So basically this PCB handles all of the control circuitry, and I think this is just going to be power supply stuff. So this little bridge connection here with these 5 pins, that's going to handle your switching, which I'm sure flows from this big triac. So that's the way this one's set up. And again, this requires a neutral in order to work. So there's something about the way this power supply works that I guess it's not able to supply power without having both the line and the neutral on this thing. So that's what this one's got inside. So now let's turn our attention to the Inovelli. So now on the Inovelli, let me see if I can pop this faceplate off easily. Oh, there we go. So there is the Inovelli. Once again, we've got 2 little switches in here. Okay, now there's also this big thing, which that's got to be, that's going to be the antenna. So now let me get the faceplate off. Pull the antenna out. That helps. Okay, there we go. Aha. All right, back off. Once again, seems that rivets playing a role. Right here underneath this little plastic mounting, we've got a couple of rivets, and here we have, it would appear, 2 components that are being heat sunk to the faceplate. So once again, let me go drill this out so I can get this thing apart. All right, well, check this out. Whenever I went to go try to drill this, I got to look and I was like, these are plastic. I wonder if I can just cut them out. So I took some little snips here, and as soon as I did this, that thing just pops out. So that's very interesting. Again, plastic rivet. Never seen that before. Thus far, the Inovelli has just way better build quality. It looks like. I mean, it just seems to be a much more expensive overall piece of kit compared to the Zooz there. So now, get this faceplate off. I mean, they're even using a little thermal pad there for their thermal mounting. Just the parts on this Inovelli, I mean, you look at the number of like little fine components. The molding that this thing uses is just, there's way more complexity to this. There we go. Try not to break this thing, but the molding, that's what was holding in. The molding on this was so tight. I mean, look at this thing. Just amazing. The parts that this thing has and the way they fit together is, whew. Like I said, this is not cheap looking. I think that's it says PC's polycarbonate, and that's very high quality parts. We got our power supply on the back here, and these are bridged, so it does have control pins bridged there, and then we've got these two big boys. And here we go. We've got two IRFB 4332s. So these, let me see if I can get those to show up. So these are Infineon in-channel MOSFETs. Pretty beefy, 60 amp rated 250 volts. It's got a couple of them there. So let's see what else we're dealing with here. It's kind of similar. We've got a little SPI flash chip. This one's still, it's an Adesto. So both of these have used Adesto SPI flash memory, so that's interesting. Let's see what we got here. Oh, on this one, I think I can get this board off. Let me see if I can get these unplugged. Yeah, there we go. Okay, so I got the boards apart. Here's the control board, and then here's, you know, all your power. So on the power circuitry here, we've got another fuse, of course, our big toroid inductor, a couple of big caps there, some other inductors and caps over here for, I'm guessing, power supply stuff. And then we've got so this big black brick, that's a Zettler relay. So that's a coil voltage of 5 volts, switching voltage up to 270 volts AC with a 10 amp rating. So pretty interesting overall with everything. This is a much more complicated board. I mean, you can see what's going on in the back of this thing, just tons of stuff. So overall, you know, thus far, I haven't actually got to the brains of this thing yet, but the Inovelli seems to be a much higher dollar system going on, because it's hard to show you the back of the Zooz, but I mean, there are very few components on the back of this. And I'm not sure, you know, I don't know enough about power supply circuitry to say if all of this is just to get this thing to work without a neutral or not. But man, is it way, way more complicated. And then we've got, here's our brains. So this is just a single-sided, mostly PC. It's got just the little connector to bridge to the power board. So let's see what we got here. Again, we've got the little SPI memory chip and then a couple of big chips with some supporting components. Like maybe an external crystal or something over here, oscillator. So on the right here, we've got a Holtec HT32F, and then it's a 52241. This is a 32-bit ARM microcontroller. Looks like it runs about 40 megahertz, and then there's a few different varieties of it. So the other chip on the left does have a little QR code sticker on it. Let me see if I can read it. And the answer is no, so that's going to have to come off. All right, so pulling up the sticker, and I'm just going to put it back down just because, again, no need to mess up more than I need to. This is a, once again, Silicon Labs chip. This is a Z-Wave chip, ZM5101A-CM3R. And so, interestingly, you know, one of the other differences, the Zooz uses a full system on a chip from Silicon Labs, whereas the Inovelli, they've got the microcontroller and the Z-Wave chip separately. And by the way, all these LEDs are because on the front, all these things out of here, on the front of the Inovelli, there's this light strip, and basically you can program a whole bunch with a button through this light strip. And so the button up here pushes this button. You can cycle through a bunch of settings, and so this whole light strip will light up with these LEDs. So very interesting differences between the engineering of these two boards. And again, they're just light switches, right? I mean, you look at all this stuff for just a light switch. Crazy. Also, I mean, this is surprisingly heavy. There's a couple of inductors under here, and then this big one. Heavy copper leads for your main you know, 120 volt, or I guess 220. I don't know if this thing will work on 220 or not. But yeah, I mean, very heavy duty on the Inovelli. It's just way different than the Zooz. I'm kind of surprised. You know, they do use some of the same components. You know, they're using the same supplier for memory chips, using the same supplier for the Z-Wave components. But once you get beyond that, quite different power supply systems, power control systems, different philosophies. Whereas, you know, you're getting a full system on a chip with a triac over here. On the Inovelli, we're separating the MCU from the Z-Wave, and we've got a couple of MOSFETs rather than a triac. Very interesting. Also, I would say, again, the Inovelli has just way more expensive looking build, way more components, much kind of overall feel of quality with that product. Very interesting stuff. Also, I would point out that the Inovelli switch, I think it was like 50 or 60 bucks. Whereas like the Zooz is like 35-ish. And so, you know, that money does go somewhere, right? This isn't arbitrarily more money. The higher price, you know, I think, again, this is an older model. I don't know if they even still sell it. I wouldn't be surprised if their newer ones, they've figured out ways to make this thing cheaper, because holy crap, there's a lot going on inside of that in comparison. And again, you can kind of see it showing up. How come this one costs twice as much almost as the Zooz? All right, so I felt a little lazy just leaving it there, and so I actually went all the way through this this Zooz switch. I did a full schematic for this thing just to figure out how it really worked, and so we can talk a little bit about this, and I'll try to contrast a little bit about how the Inovelli differs from it. So on this one, you've got your lugs and line neutral on this end of the PCB, and then you've got your load and the traveler for the three-way switching over here. And I removed this huge inductor on the top just so I could see if there was anything under it and kind of follow the traces. These two boards were originally connected through these big pins that go through, and basically those come through to the two legs of the triac. So this board handles big power on the back, and then the low voltage power supply basically on the front. This board handles all the actual brains. You've got your microcontroller and your whole system on a chip here. I think earlier I'd said that this was a SCA3502A. That is just the main chip on it. This whole thing is sold as a module from Silicon Labs. That's the ZM5202 module. I think it's deprecated at this point, but that basically handles everything. This chip is an AT45DB021E, and that's just some SPI flash memory. I think it's 2 megabit. And up here, we have a BTA24-600B. This is a triac. You got a couple buttons here. You've got a trace and this wire for the antenna. And then there was a pin header. So on the top, there's a 0 voltage crossing point sense pin that feeds information back to the microcontroller, because this triac, I think they're switching it at the 0 voltage point on the AC signal. I believe maybe you have to on triacs. You've got the signal pin for the three-way. The switching, by the way, happens on this board, and they're basically, the three-way switch is controlled by a transistor right here. Best I can tell, that's a BC847C, which it's labeled 1G. And there's a few of these transistors that are used to switch things on this board. So there's one up here. This switches the triac, so everything up here is circuitry for the control of triac. You've got this one here, which is apparently switching somehow or sensing somehow from the traveler on the three-way. You've got another one here. This actually goes to the output pin for the 0 crossing. So this transistor, let's see if I can point a little bit better. This transistor right here, that's the one that leads off to the 0x pin, or the 0 crossing pin. The chip here in the middle, that is a LNK304DN. Basically, this is an integrated AC-DC converter. And so this thing is dropping down the voltage to 12 volts. And then up here, we've got a LDO. This is a 7533-1. And so this is then dropping the 12 volts down to 3.3 volts. And you've got 3.3 volts in ground being sent up to this board through that link to power everything over here that needs 3.3 volt supply. So the power basically is coming in. You've got a big capacitor. You've got this green thing is a varistor. That's a 07D241K. You've got a 250 volt 5 amp fuse that's coming in here. That feeds into the power rail that this AC-DC converter, this LNK304, is using. And so again, that's basically what they're using for power. Now, this big switch on the bottom is basically just a mechanical on-off for everything. I guess if you're working on the circuit, this is so that you can kind of manually disconnect without having to use the breaker is all I can figure. It's kind of weird because this switch is only rated at 5 amps at 120 volts. I'm not sure. Does it say what the rating is on this switch? But that's pretty low, 5 amps at 120 volts, considering this is probably going to be put on a 15 amp circuit. I don't know. I don't know, what code says on that. Anyway, that's basically it. Now, as far as the main power switching, again, you've got your controller here, again, the Silicon Labs module. And so whenever you flip these buttons, these are just being pulled to ground as you push or flip that switch. And the signal comes up a little trace. And again, they're using a transistor here on this G leg to switch this triac. And so the power's coming here. It's going through the fuse into the triac. It's coming out of the triac here. It goes through this huge inductor and then jumps down here. And so this is the lug for the load. And so that's how it does its switching. Again, fairly low component count, I feel like, for everything that they're accomplishing. This stuff's not very cheap. This module, even in volume, still seems to be 11 or 12 bucks alone. And so seems to be, low part count, but a very kind of concise way to do things. Now, I didn't fully track everything on the Inovelli, but I can talk a little bit about the differences. Again, they've got their microcontroller separate from the Z-Wave system, and they're still using pretty much the same SPI memory chip. I think it's just a slightly different version, maybe a slightly different size, but everything else is pretty similar. All of the brains and low voltage circuitry is on this board, and then the other board handles the power supply and the high-level switching. Interestingly enough, they're using almost exactly the same AC-DC converter chip, but they've got a ton more circuitry. I can't find an LDO, so I don't know if they're kind of discreetly doing their low voltage on this side. And again, they're using a couple of MOSFETs to do their switching in addition to this big relay. So I'm not really sure what all's going on here, but I guess maybe some of this is required for that Inovelli system, because on this system, I believe they don't require a neutral. And so that's one of the major differences in what they've got, other than, of course, different designers. But, they're using a big relay and a couple of MOSFETs over here. Much higher component count, way more complicated. That's why I didn't trace everything out. But that said, I'll put up the schematic for this thing. I can't guarantee that it's 100% perfect, but it ought to be pretty close. And I identified as many components as I could. The only things that are really left unidentified are some of the capacitors and inductors, because I didn't want to desolder them. And you can't really measure them very well while they're in the circuit, but pretty much every semiconductor on here, all of the transistors, all of the diodes, all of the resistors, and all the main components are even labeled on the schematic. So if you really want to see how this thing works, you can look up, spec and data sheets and everything else for basically everything that's on here. So I feel like that's probably a good place to stop. Hopefully this video hasn't been too long. Hopefully you found it pretty informative. I certainly have. I didn't even know that these all-in-one AC-DC converters existed, I don't guess. They don't put out a ton of power. I think it's something like 150 to 200 milliamps is all they can supply. But given that there's basically no heat sinking or anything else, that's pretty darn good for an all-in-one solution, no transformer or anything required. So anyway, that's where I'll stop this. If anybody has any feedback, comments, anything else you'd like to see on these, please let me know, and I'll try to respond. Otherwise, I appreciate your time.